Hello, welcome to Algebra 1 with Miss Betsy. We're finishing up the chapter that we've been doing where we're talking about working with radical expressions. What we're going to be talking about today involves dividing radical expressions. We're also going to learn what the conjugate of a radical is and how you use that to simplify expressions that contain radicals. Before we start though, there's this story in my joke book, and it says, one morning, a man telephoned his neighbor at 4 o'clock in the morning and said, "Your dog is barking and keeping me awake." So, the neighbor politely thanked him and hung up the phone. The neighbor, however, called him back the next morning at 4 o'clock and said, "I don't have a dog." So, it sounds to me that that was probably two males communicating with one another. So we're going to be dividing radical expressions as I turn back here to look at my empty board. And you learned that earlier on in this chapter, you learned that in order to have an expression that contains a radical, in its most simple form, you could not have that radical symbol in the denominator. So in order to, and we would rationalize this by multiplying by the square root of 2 over the square root of 2. Even though the square root of 2 over the square root of 2 looks a little bit weird, it's nothing more than multiplying the expression by 1. So it changes the appearance but doesn't change the value. We saw that when we multiplied this out, we ended up with 3 times the square root of 2 over 2. And all of your math teachers are happy because you have now rationalized this expression so that there are only rational numbers in the denominator. Well, it was all well and good when you had a simple expression with a radical that looks just like this. Well, what are you going to do, however, when you have in the denominator something that looks like that? You have the square root of 2 plus 1. Well, you know that you can't multiply by just the square root of 2, you wouldn't think, or can you? Well, we've got the square root of 2 here. What happens if we multiply the numerator and the denominator by the square root of 2 over the square root of 2? 3 times the square root of 2, square root of 2 times the square root of 2 is the square root of 4, plus square root of 2 times 1 is the square root of 2. We're going to end up with 3 times the square root of 2 divided 2 plus the square root of 2. Haven't accomplished anything, have we? We know that we have to get rid of the radical symbol and the denominator. The only thing that we knew how to do was to multiply by the square root of 2 over square root of 2. But as I've illustrated right here, doesn't work when you have more than one term in that factor in the denominator. So what are you going to do? And this is where we are going to multiply by the conjugate of the expression. Let's go back and use exactly the example that they're talking about, using in your book. 4 divided by the square root of 2 minus 1. Let me make sure that I have this exact here. 4 divided by the square root of 2 minus 1. And I don't believe I said on this video, I'm using as my text Algebra 1 for Christian Schools, published by Bob Jones University Press, 2nd edition. I am now on page 432. Don't have to use that same text. This idea of multiplying by the conjugate is going to be the same whatever text you use. But let's go ahead and define what the conjugate of a radical expression is. It's simply the radical expression itself with the opposite sign. Square root of 2 minus 1. Its conjugate would be the square, not the square root of the square root. Root would be the square root of 2 plus 1. The conjugate of a radical expression is simply that identical radical expression with the opposite sign. So here is our original expression, our original radical expression. Here is its conjugate. Those of you who take a foreign language or are really into English grammar, when you conjugate something, you get different verb forms spelled exactly the same way, but it's not conjugate, it's conjugate here in English. So the conjugate of a radical expression is the radical expression itself, where you have simply changed the sign for that. And what's the value of doing that? What does this look like to you? Remember, they're not polynomials, not binomials, but it's like an algebraic binomial. X minus y, x plus y. That works out to be the difference of two squares. So when you multiply a radical expression by its conjugate, that will cause those radical signs underneath, radical signs in the denominator to go away. Let me go ahead and illustrate this to you. We have the square root of 2 minus 1 in the denominator. We're going to multiply by the conjugate, which means we're going to multiply by the square root of 2 plus 1. The only way that we're allowed to do that is that we can multiply this expression here is if we multiply it by some value, some expression that's equal to 1. So you multiply the numerator and the denominator of this radical expression by the conjugate of the radical expression. In your numerator, you now have 4 times the quantity square root of 2 plus 1. In the denominator, you now have something that works just like the difference of two squares. We're going to distribute the 4. In our numerator, we have 4 times the square root of 2 plus 4 times 1. 4 times square root of 2, I don't need those parentheses there. 4 times the square root of 2 plus 4 times 1 is 4. Divided by square root of 2 minus 1, square root of 2 plus 1. It's the difference of the squares of the terms. Square root of 2 squared minus 1 squared. What do we have? 4 times the square root of 2 plus 4 divided by square root of 2 squared is 2 minus 1. 4 times the square root of 2 plus 4 divided by 1. What's our answer? It's just 4 times the square root of 2 plus 4. Multiplying by the conjugate of a radical expression is a very straightforward process, provided you understand and you remember how you end up with the difference of two squares, and that you've practiced your multiplication enough so that you know how to deal with these radical expressions. Let's go ahead and do another example for you. Example 2, we have the square root of 3 times 2, square root of 3, whoops, we don't have the square root of 3 times 2, we have 3 times the square root of 2, 3 times the square root of 2 plus 4 divided by the square root of 5 plus the square root of 3. And you see how there's nothing resembling arithmetic in here anymore, is there? Nothing resembling pre-algebra. You're solidly into Algebra 1. You have radical symbols in the denominator that you know you're not allowed to have, so you have to rationalize it. You can't simply multiply by the square root of 5 because you have two terms in this denominator. Two terms here, square root of 5 plus 3. We're going to multiply by the conjugate of this. And what is our conjugate? Our conjugate of that radical expression is exactly the same with the exception of the sign between the terms. And you have to multiply both the numerator and the denominator by that conjugate, because here, this, even though this looks like a mess, square root of 5 minus 3, square root of 3 divided by square root of 5 minus square root of 3, that's just another way to express 1, which allows us to do this. Now, we have in the denominator here, the product will be the difference of two squares, which eliminates our radical symbols. What do we have to do in the numerator, though? Well, we're going to FOIL in the numerator. And I'm going to go ahead and write all of our partial products out. What happens when I multiply the first terms together? Well, that's 3 times the square root of 2 times the square root of 5. What's our outer product? It's a negative minus 3 times the square root of 2 times the square root of 3. What's our inner product? Plus 4 times the square root of 5. And what's our last product? Our last product is 4 times the square root of a negative 3, so it would be minus 4 times the square root of a negative 3. This is just getting to be a whole bunch of mess right there, isn't it? And yes, your answer is going to be long in this particular problem. Anytime I have a big old long string of algebra that I'm writing here, I take the time, even part of the way through, to make sure I've done my multiplication or whatever properly. So the first term's 3 times the square root of 2 times the square root of 5. 3 times square root of 2 times square root of 5. The outer term is negative 3 times the square root of 2 times the square root of 3. The inner product, plus 4 times the square root of 5. The last product, plus 4 times the negative square root of 3 minus 4 times the square root of 3. Blech. Okay, what do we have in the denominator? Now the denominator is nice because we're rationalizing this denominator. We're eliminating the radical signs here by multiplying by the conjugate of this radical expression, which ends up being the difference of two squares. So you have the square of the first term minus the square of the last term. Now that's nice. That's much nicer than this mess we have up at the top. But let's go ahead and simplify now. 3 times square root of 2 times the square root of 5 becomes 3 times the square root of 10 by the product property for radicals. Minus 3 times the square root of 6 plus 4 times the square root of 5 minus 4 times the square root of 3. All of this divided by square root of 5 squared is 5 minus the square root of 3 squared is 3. Now let's see what we can combine. We're going to combine like terms. Look at this awful mess that we have up here in the numerator. We want to combine things, right? Make it more simple. How do you determine if a radical is a like term? Well, you have to have exactly the same number under the radical symbol, and we have none that are the same. So there is nothing that we can combine in this numerator. Square root of 3 times 10 minus 3 times the square root of 6 plus 4 times the square root of 5 minus 4 times the square root of 3 divided by 2. We have accomplished our purpose. And this is a really good example of what I was talking about in class the other day. Remember, I said sometimes when you're dealing with these radical symbols, with expressions that contain radical symbols, and you end up with the proper form or what is supposed to be simplified, you're going to look at that answer and you're going to say, how in the world is that more simple? What we started with was this pretty straightforward expression right there. We rationalized the denominator, which meant that now we don't have any radical symbols in the denominator any longer, but we've got a long stretched out problem. This is not completed. This is your final answer. It is what it is. Let's go ahead and look at another example. As soon as I get my markers back together. I'm on page 433, and I'm going to do one where we just have variables within the radicals. Let's see what we can do. This is example 3 on page 433. And it says, simplify the square root of m minus the square root of n divided by the square root of m plus the square root of n. Don't be afraid of this. It's just full of letters. There's no numbers in there. But you can do this. The principles and the patterns and the methodologies that you use when you're using numbers work with just the variables as well. Can we multiply just by the square root of m or the square root of n if we want to rationalize that denominator? No, you have to multiply by the conjugate. And the conjugate is the same as the rational expression, just simply the sign is different. Square root of n plus n. The conjugate is the square root of n minus n. Multiply the numerator and the denominator by the conjugate. Okay? What do we have now? We go ahead and just write all of this together. Because when you multiply rational expressions, you multiply the numerators, you multiply the denominators. So we have the square root of m minus the square root of n times the square root of m minus square root of n. That same factor is squared, correct? And then down here, in the denominator, square root of m plus square root of n times square root of m minus square root of n. We have two special patterns, two special products that we recognize here. This is a perfect square trinomial. I wrote it like this so you'd see it's a perfect square trinomial. And that product is the first term squared. We keep the sign minus twice the product of the first and second terms, twice the product of those terms, plus the last term squared. Square root of n, it's interesting that I read it too, the square root of n squared, all of that is divided by this product, which is, remember, this is the difference of two squares. This is why we multiply by the conjugate of a radical expression, because we end up with the difference of two squares in the denominator, and those radical symbols go away. So that becomes square root of m squared minus square root of n squared. So now let's go ahead and carry out our multiplication and see what we have. So we have m minus 2 times the square root of m times n plus n divided by m minus n. Now, let me find my marker lid here and let's step back for a moment and see what we have with this problem. And let's see what they're trying to illustrate to you here so that you don't fall into the trap that they've laid for you. First, let me verify that I've gotten everything correct. Yes. When you are reducing a fraction, you cancel common factors, correct? So if you have 10 16ths and you factored this, you could have this be 2 times 5 divided by 2 times 8, and you would cancel common factors, correct? However, if you had 7 over 2, would you be able to say, well, that's 2 plus 5 divided by 2. Okay, this would, we've canceled common factors and ended up with 5/8. Here we have 7/2. Can we say, well, 7 is the same as 2 plus 5? Cancel those 2's and say that 7/2 is equal to 5? Well, no, obviously you can't. That just is ingrained in you now. You would never make that mistake. Don't do the same thing here. These are not factors. You can only cancel common factors. It is not true that you can say you can cancel a factor of m and you can cancel the n's. They're not factors. These are terms. You may only cancel common factors. You may not break something apart into addends and then cancel those. Okay? Point of all of that? This is your final form of this expression rationalized. Take a lot of time to work with these. Don't rush through them. Don't play on your iPhone. Don't text. Don't watch a movie. Get yourself a drink and a snack if you need. But sit down and apply yourself to your math so that you're following every step that you're doing. Everybody, make sure you show me your work. Okay? Enjoy these, and I'll see you next time.